going to discuss about a case study on robotic manipulation. So this manipulation is nothing but the movement, robot arm and leg movement. So if we take a case study, we can go with a film like Indian movie. We have noticed some moments where Rajinikanth will be struggling with the robotic arm movement. You have seen that scene, right? Everything will be fabricated and connection, wiring, everything can be completed. But the finishing touch, where the robot arm movement according to the algorithm is the very difficult task. So there comes a case where the movement of the robot is very important. For example, grasping an object, picking and placing an object, and movement of one place to another. So everything comes under this manipulation. So this concept plays a vital role because as a mechatronics engineer, we can develop n number of robots. But the robot should perform a specific task which is required by the customer. Either it may be a simple grasping or pick and place. So let us discuss this application into a deeper sectors like what is the working process, what is the algorithm we needed, what is the challenges we are facing, and what will be the future scope we can develop. So starting from our concept, can you explain me the concept of this?
Yes ma'am, let me give an overview of this concept. First, let's consider a real world problem like Boston or Amazon services. They use autonomous bots for pick and placing. So it should navigate through the paths properly and should grasp the objects properly. So taking the case of a robotic arm, it must grasp any kind of or any shape of objects properly, and it should not leave it and grip it really good so that it can move from one place to another place without damaging the object. And the challenges include that the path should not have any interruptions so that the arm is gripping it properly. And the next is placing them in the proper places, which allocated places. As you said, there is many like inefficiencies that will be happening now. So we need to reduce that risk so that making our product more reliable to the industries now. And the traditional programming becomes difficult because we have many modern applications, we have raw systems and everything to automate it. So automating it properly will be help our system to make the object grasp properly, pick them properly from the place and place it in the proper boxes it needs to be placed, ma'am.
Good. So next, what will be the working flow components?
In system components, robot manipulator is multi-degree freedom robotics like industrial robotic arm and collaborative robotics. We use a sensors like cameras and depth sensor and force sensor and textile sensor. Then we use the sensors to help object position and shape and orientation and grip precision. And reinforcement learning like observe the environmental task and actions and receive rewards and learns better manipulation. And environment object and workshop and obstacle and target. That's all.
Okay, let me explain about the working principle of that. Working principle of RL manipulation. The robot observes object location, arm position, and the sensor movement. It takes some possible actions like move arming, rotate grips, open and close fingers, like that and all. Receive rewards like +10 for successful grabbing, and -5 for grabbing an object, and -10 for corruption. The robot objective is to maximize and then collect what the object is near front of you. The fundamental RL equation used to learn as Q is equal to quality of action, R is equal to reward, and gamma discount factor, and S is equal to next statement. And that's it.
Now we go to the challenges, ma'am. Sample inefficiencies. Training requires enormous data and long training time. Learning complex manipulation can take days or weeks. And safety corners. Robots may damage objects, cause collisions, and perform unsafe during the learning. Sim to real gap. Qualifies training in simultaneous may not work perfectly in real environment, and the applications are manufacturing assembly robots and quality inspections.
So now we are clear about the robot manipulation and what is the algorithm implemented in working flow challenges. So next we will work on these challenges, and a challenge will be be mapped in with an application. So in the next upcoming sessions, we will work on it and we'll get some solutions for that.
Yes.
Thank you.
Thank you.